Hello and welcome to Grace tutorial. In this video lecture, we will be discussing about the part 3 of the chapter acids, bases as well as the salt. But first up, if you are the new viewer, then I would request you to watch the first as well as the second part of this chapter so that it will be easy for you to understand. Well, here we are going to discuss the entire things about the bases. First of all, let us try to understand that what does the term base refer to? Well, basically, a base is either a metallic oxide or metallic hydroxide or ammonium hydroxide which reacts with the hydronium ions of an acid to form the salt and water only. So this is the definition of the base that I have written for you. A base is either a metallic oxide or the metallic hydroxide or ammonium hydroxide. You need to remember these three terms: metallic oxide, metallic hydroxide or ammonium hydroxide. That means a base is either a metallic oxide or a metallic hydroxide or ammonium hydroxide, and these react with the hydronium ions of the acid to form the salt and water only. This only is a word which is used here particularly. Why? Which we'll discuss slightly later, that why this only has been produced here. So this is the definition of the base. Now let us see some of the few examples of the base so that you get it very clearly. Well, you look at here, we have the various bases, and whenever a base reacts with the acid, then what happens? A salt is formed along with the water. For example, when the copper oxide reacts with hydrochloric acid or hydrogen chloride, then what happens? Then copper chloride is formed. But now we need to understand that how this product is obtained from this reaction. First of all, let us write this CuO, that is copper oxide. If you will dissociate the copper oxide, then what do you get? You get Cu2 plus O2 minus. And if you will dissociate this hydrochloric acid, then you will get H plus Cl minus. That means the positively charged part of this compound will react with the negatively charged part of this compound. That means the Cu2 plus will react with the Cl minus to give the CuCl2. So this is what the product that it has been obtained here in this first reaction, that is CuCl2 along with the liberation of the water molecule. That means here only the water molecule is obtained but not any other molecule. So whenever a base reacts with the acid, then it forms a salt with the water molecule. So that's what all we have written there in the definition, that a base is either a metallic oxide or a metallic hydroxide or ammonium hydroxide. This is basically a metallic hydroxide. When the magnesium hydroxide reacts with sulfuric acid, what happens? The magnesium sulfate is formed with the liberation of the water molecule. That means only the water molecule is formed but not any other molecule. Similarly, when the aluminium hydroxide reacts with nitric acid, then aluminum nitrate with the water molecules are obtained. Similarly, we have ammonium hydroxide. When this ammonium hydroxide NH4OH reacts with HCl, it gives ammonium chloride with the water molecule. That means the water molecule is obtained here along with the salt. So once again, if you will remember the definition very clearly, then that it would be very clear that base can be a metallic oxide or a metallic hydroxide or the ammonium hydroxide that reacts with the hydronium ions of the acid to form the salt as well as the water. So this is what the base, as well as we have given the various examples of the bases. Whenever it reacts with the acid, then it forms the salt as well as the water. That's all about the definition along with the examples of the bases. Now we will discuss the basic oxide. So we will discuss a basic oxide. So a basic oxide is a metallic oxide which contains the ions O2 minus and reacts with an acid to form the salt as well as the water only. So this is the definition of the basic oxide. This basic oxide contains that metallic oxide, and it is the metallic oxide. It contains O2 minus, and when it reacts with the acid, then it forms the salt as well as the water only. Here the only word is used here. So let us have a look at some of the examples. Well, we have lead oxide. When this lead oxide reacts with HCl, then we get lead chloride with chlorine molecule as well as the water molecule. That means here the only is the word which is excluded from the classes of the base. That's why this lead oxide is not a base. Now we will discuss the basic hydroxide. So what do you mean by this basic hydroxide? It is a metallic hydroxide which contains the OH minus ion, and when it reacts with an acid, it gives the salt as well as the water only. The definition of basic oxide and basic hydroxide is almost same, but in case of this basic oxide, here it contains the ion water minus, but here it contains the OH minus ion, and both react with the acid to give the salt as well as the water. For example, we have sodium hydroxide. When the sodium hydroxide reacts with HCl, then the positively charged part of the sodium hydroxide will react with the negatively charged part of this HCl. So the positively charged part of the sodium ion from the sodium hydroxide reacts with the Cl minus ion, which is from the HCl, to give the sodium chloride with the liberation of the water molecule. So this is all about the basic hydroxide. Now we'll move on to the next one. So what do you mean by this alkali? An alkali is a basic hydroxide which when dissolved in water produce hydroxyl ions as the only negatively charged ions. For example, we have sodium hydroxide. When the sodium hydroxide is dissolved in the water, it dissociates to give the Na plus as well as the OH minus. That means the hydroxyl ion is released from here. You need to mention here that an alkali is a base. An alkali is a base and it is soluble in water. And all alkalis form the hydroxyl ions in the aqueous solutions, and they turn the red litmus into the blue color, so that we can easily understand that these are the bases. Let me give you some of the few examples of the bases. Or we have sodium hydroxide, we have potassium hydroxide, calcium hydroxide and ammonium hydroxide. These are the bases. But if you look at the first two bases, that we have sodium hydroxide and potassium hydroxide, these are the strong bases. Why? Because they can easily react with the water. But if we look at this calcium hydroxide and the ammonium hydroxide, they are feebly dissociated with the water. Hence they are the weak alkalis, and these are the strong alkalis, hence these are the weak alkalis. But you need to remember here that all the alkalis are the bases, but all the bases are not the alkalis. Why? Because there are some of the bases which do not dissolve with water, which do not react with the water. For example, we have the ferric hydroxide and cupric hydroxide, and this ferric hydroxide and the cupric hydroxides are the bases, but these are not alkalis because these do not dissolve with the water. How the sodium hydroxide, potassium hydroxide, calcium hydroxide and the ammonium hydroxide dissolve with the water, and these ferric hydroxide and the cupric hydroxide do not dissolve with water. And since they are insoluble in water, since these two compounds are insoluble in water, that's why they do not come under the alkali category. That means an alkali is a base which is soluble in water, but the base should, if the base is soluble, then that is called basically alkali. So we need to remember here that all the alkalis are bases, but not all the bases are alkalis. So that's what all about the alkalis. Now we will discuss the classification of alkalis. Well, on the basis of their strength, the bases or the alkalis has been categorized into two types. One is the strong alkali and number two, the weak alkali. That means, what do you mean by the strong alkali? When a substance undergoes the complete dissociation in the aqueous solution, producing a high concentration of the OH minus ion, then that alkali is what basically called the strong alkali. That's why I have written here the definition. It undergoes almost complete dissociation in aqueous solution to produce a high concentration of the OH minus ion. So when there is a complete dissociation in the aqueous solution, then that alkali is called the strong alkali. For example, we have sodium hydroxide. When the aqueous solution of the sodium hydroxide is dissociated, it gives the Na plus and OH minus ion. That means the hydroxyl ion is produced here. Similarly, we have another strong alkali, that is potassium hydroxide, and the aqueous solution of the potassium hydroxide, when it is dissolved in the water, it gives the K plus as well as the OH minus ions. So what do you mean by strong alkali? The alkali is said to be strong when it undergoes a complete dissociation in the aqueous solution to produce a high concentration of the OH minus ion. But if that substance undergoes a partial dissociation, or if that substance undergoes a feeble dissociation or ionization in aqueous solution to produce the low concentration of the OH minus ion, then that substance or that alkali is what basically called the weak alkali. That means it undergoes only a partial dissociation or ionization in aqueous solution to produce a low concentration of the OH minus ion. So let us have a look at some of the few examples of the weak alkali. So ammonium hydroxide is a weak alkali because on dissociation with water, what happens? It gives NS4 plus and OH minus ions, but a low concentration of the OH minus ion is obtained. Similarly, we have calcium hydroxide, and when this calcium hydroxide on dissociation with water, then what happens? It gives the Ca2 plus with a low concentration of the OH minus ion. Now someone may ask you that what's the difference between the strong alkali as well as the weak alkali? Then you need to say that a substance is said to be a strong alkali if it undergoes a complete dissociation in the aqueous solution producing a high concentration of the OH minus ions. These are the examples. And a substance is said to be a weak alkali if it undergoes a partial dissociation or ionization in the aqueous solution to produce a low concentration of the OH minus ion. And these are the examples of the weak alkali. Now we will classify the bases on the basis of their acidity. So on the basis of their acidity, these bases have been classified into various categories such as monoacidic base, diacidic base, triacidic base. But we need to understand that what do you mean by this acidity? Well, the number of hydroxyl ions which can be produced per molecule of that base in the aqueous solution is known as the acidity. That means the acidity of the base depends on whether the base is monoacidic base or diacidic base or the triacidic base. That means if the one hydroxyl ion is produced when that substance dissociates in the aqueous solution, then that comes under the monoacidic base. That means the monoacidic base is that base which on dissociation in the aqueous solution furnishes one hydroxyl ions. For example, we have sodium hydroxide, and when the sodium hydroxide dissociates in the aqueous solution, what happens? We get Na plus and OH minus ion. Similarly, the potassium hydroxide, when the potassium hydroxide dissociates in the aqueous solution, we get K plus and OH minus ion. Similarly, we have ammonium hydroxide, NS4OH. When this dissociates in the aqueous solution, we get NS4 plus and OH minus ion. So if you will observe it very carefully, in all these three compounds, we have we have each hydroxyl ions. That means when a substance on dissociation in the aqueous solution furnishes one hydroxyl ion, then that substance is called the monoacidic base. So what do you mean by this diacidic base? It's very easy to understand, my dear students. Whenever that substance undergoes the dissociation and it furnishes the two hydroxyl ions, then those substances are called the diacidic bases. So what are the examples? We have calcium hydroxide. Whenever the aqueous solution of the calcium hydroxide dissociates in the aqueous solution, what happens? We get the Ca2 plus as well as 2 hydroxyl ion. Similarly, when this copper hydroxide on dissociation, we get the Cu2 plus as well as the 2 hydroxyl ion. That means here we need to understand from here, in these compounds the 2 hydroxyl ions are obtained. in these compounds, since these two hydroxyl ions are obtained, therefore these substances come under the diacidic base. So that base is said to be diacidic base, which on dissociation furnishes two hydroxyl ion, but that base is said to be the monoacidic base, which on dissociation furnishes only one hydroxyl ion. Similarly, if any substance on dissociation in the aqueous solution furnishes the three hydroxyl ions, then those substances are called the triacidic bases. So here we have written the two examples of the triacidic bases: aluminium hydroxide and ferric hydroxide. So whenever you will dissociate the aluminium hydroxide in the aqueous solution, what happens? You will get the three hydroxyl ions. Similarly, whenever this ferric hydroxide is dissociated in the aqueous solution, what do you get? You will get the three hydroxyl ions. That's why it comes under the triacidic base. So I hope you understand the monoacidic base, the diacidic base and the triacidic base. In monoacidic base, only one hydroxyl ion is obtained on dissociation, but on dissociation it gives the two hydroxyl ions in case of this diacidic base. And in case of this triacidic base, the three hydroxyl ions are obtained. That's why the name triacidic base is given. So that's all about the classification of bases on the basis of their acidity. Now we will discuss the preparation of bases. Well, if we look at the preparation of the bases, we have the first method, that is from metals. Now, how can we prepare the base from the metal? Whenever the metal reacts with oxygen, it gives a base. That means the metal oxide is produced. So the metal oxide is a base. For example, we have sodium. The sodium is a metal. When it reacts with oxygen, it gives the sodium oxide. That is, the sodium oxide is obtained here. And how this product has been obtained, let us try to look at here. We have sodium. So what is the charge of the sodium? Na plus and oxygen. This is O2 minus. And if you will, in this way, we have Na2O, that is sodium oxide is obtained here. So this is what we had already learnt in the 9th standard. Well, the cross connection. Whenever the sodium reacts with the oxygen, it gives the sodium oxide, which is a base. Similarly, when this magnesium reacts with oxygen, it gives the magnesium oxide. How? Magnesium means we have magnesium ion Mg2 plus and oxygen O2 minus. So what happened here? Here the charge will come here and the charge of this oxygen will come under this category, and finally you will get MgO, that is the magnesium oxide. So the magnesium oxide is basically a base. And how the base is produced? By the reaction of the metal with oxygen. So this is the first method, that how we prepare the base from this method. Now we'll move on to the second method. So what does the second method say? By the action of water on the reactive metals. That means whenever the metals react with water, then what happens? Then a base is obtained. Let us look some of the examples so that you get it very easily. Not only the base, but also the hydrogen gas is evolved or it liberated. For example, we have sodium. When the sodium metal reacts with water molecule, then what happens? It gives the sodium hydroxide with the liberation of the hydrogen gas. Now you may have a doubt that how this product is obtained from these two. Let me give you an idea. That is, we have Na plus. When the sodium, if you will write what is the charge of the sodium, we have plus 1. That is what we have written, Na plus. And 2 H2O. That means if you will dissociate H2O, you will get H plus and OH minus. So the positively charged part of this Na plus will react with the negatively charged, that is OH minus. So in this way, Na plus and OH minus produce the NaOH, that is sodium hydroxide, with the liberation of the hydrogen gas. Similarly, we have the potassium. When this potassium reacts with the water molecule, in the same way, the K plus, the positively charged part of this K plus will react with the negatively charged part of this potassium hydroxide. So negatively charged part of this water molecule, so that it gets the potassium hydroxide with the liberation of the hydrogen gas. Similarly, we have another example, that when the calcium reacts with the water molecule, what happens? The OH minus ion of the water molecule will react with the calcium to give the calcium hydroxide with the liberation of the hydrogen gas. That means whenever a reactive metal reacts with the water, it forms the base or alkali with the evolution of the hydrogen gas. So in which case, when the hydrogen gas is obtained, whenever a metal reacts with any other substances, you need to say that when the metal reacts with the water, it gives the alkali or the base. But which gas is obtained? Here the hydrogen gas is obtained. So that's all about the method number 2. Now we will move on to the method number 3. By the action of water on soluble metallic oxides. That means when the metal oxide reacts with water, what happens? Here the base is obtained. So the base is also obtained in some different method. When the metal oxide reacts with water, the base or the alkali is obtained. Right? We have the various examples. We have whenever the sodium oxide reacts with water molecule, what happens? The sodium hydroxide is obtained. That how the sodium hydroxide is obtained? Let me write here. If you will dissociate the sodium oxide, you will get Na plus and O2 minus. And if you will dissociate this H2O, you will get H plus and OH minus. So the positively charged part of this compound will react with the negatively charged part of this compound. That means Na plus and OH minus, they will react with each other to give the NaOH, that is sodium hydroxide, which is a base. That means whenever the metal oxide like the sodium oxide reacts with the water, it gives the sodium hydroxide. Similarly, we have the potassium oxide. Whenever this potassium oxide reacts with the water molecule, then how the potassium hydroxide is formed? Let us see how. If you will dissociate this potassium hydroxide, you will get K plus potassium oxide, you will get K plus and O2 minus. And if you will dissociate this H2O, you will get H plus and OH minus. So the positively charged part of this compound will react with the negatively charged part of this compound to get the K plus and OH minus. They react together to give the KOH. So that is what we have obtained here. We have got here as a base. That means the potassium hydroxide is a base which is obtained by the reaction of the potassium oxide with water molecule. Similarly, we have calcium oxide. Whenever this calcium oxide reacts with the water molecule, what happens? The calcium hydroxide is obtained. How? If you will dissociate this calcium oxide, you will get Ca2 plus and O2 minus. And the water, H plus and OH minus. So the positively charged part of this compound will react with the negatively charged part of this compound. That means the positively charged part of this calcium oxide, that is Ca2 plus calcium ion, will react with the negatively charged part of the water molecule. That means the OH minus ion to form the calcium hydroxide, which is a base. In this way, the metallic oxide reacts with the water molecule to form the base or alkali. So we have now the fourth method, that is by double decomposition. Well, you see, salt solution, whenever the salt solution reacts with a base or alkali, then we get the basic hydroxide with the normal salt. And all the basic hydroxides which are obtained here, these are the precipitates. That means the various precipitates are formed. Well, let us take the example so that you can understand it very easily. We have ferric chloride, and when this ferric chloride reacts with the sodium hydroxide, then we got the ferric hydroxide, which is a precipitate, and a normal salt, that is the sodium chloride, is obtained here. But we need to understand that how this product is obtained by the reaction of this ferric chloride and sodium hydroxide. Let us have a look. If you will dissociate this ferric chloride, then what do you get? You will get Fe3 plus and Cl minus. And if you will dissociate this sodium hydroxide, what you will get? You will get Na plus and OH minus. So the positively charged part of this compound, that means the Fe3 plus, will react with the negatively charged part of this compound, that means OH minus ion. That means the positively charged part of this compound, that is FeCl3, react with the negatively charged part of the sodium hydroxide molecule. And in this way, so Fe3 plus reacts with the OH minus ion to form the FeOH whole 3. The ferric hydroxide is obtained, which is basically a precipitate. Similarly, we have another example, that is copper sulfate. When this copper sulfate reacts with the sodium hydroxide, then it gives the copper hydroxide, which is a precipitate, with the sodium sulfate, which is a salt. But how this copper hydroxide is formed, we need to understand. Well, if you will dissociate this CuSO4, you will get Cu2 plus and SO4 2 minus. And if you will dissociate this NaOH, you will get Na plus and OH minus. So here the positively charged part of this copper sulfate reacts with the negatively charged part of the sodium hydroxide, that is OH minus ion, to form the CuOH whole 2, that is copper hydroxide, with the formation of the normal salt. Similarly, we have another example, that is aluminium chloride, and whenever this aluminium chloride reacts with the ammonium hydroxide, then what happens? This aluminium hydroxide with ammonium chloride is obtained. But how this product is obtained? Let us have a look. We have aluminium chloride, and if you will dissociate the aluminium chloride, then what happens? You will get Al3 plus and Cl minus, and if you will dissociate this ammonium hydroxide, you will get NH4 plus and OH minus ion. That means the positively charged part of this compound will react with the negatively charged part of this compound. That means the Al3 plus will react with the OH minus ion to give AlOH whole 3, that is aluminium hydroxide, which is basically a precipitate. And here this NH4 plus, it reacts with the Cl minus to form the NH4Cl. In this way, the ammonium chloride form, the normal salt is also obtained by this reaction. Well, here in this reaction, what did we learn? By double decomposition. That means whenever a salt solution reacts with the base or the alkali, then we get the basic hydroxide with the normal salt. So there is the formation of the double decomposition, and by this double decomposition, the basic hydroxides and normal salts are obtained. So this is what the method number 4 of the preparation of the base. Now we will look at the fifth method, says by the action of oxygen on metal sulfides. That means when the metallic sulfide reacts with oxygen, what happens? The metallic oxide is formed with the evolution of the sulfur dioxide gas. Well, we have the zinc sulfide. Whenever the zinc sulfide reacts with oxygen, then zinc oxide is obtained with the evolution of the sulfur dioxide gas. Now we'll look at this, how this zinc oxide is obtained. If you will dissociate this zinc sulfide, then what do you get? Zn2 plus and S2 minus. And if you will dissociate this oxygen, you will get O2 minus. So the positively charged part of this compound will react with oxygen. Anyhow, it is a negatively charged ion, that is oxide ion. So it reacts with this oxide ion to give the zinc oxide with the evolution of the sulfur dioxide gas. In this way, the zinc oxide is obtained by the reaction of zinc sulfide and oxygen. Similarly, we have another example, that is lead sulfide. Whenever this lead sulfide is also a metallic sulfide. Whenever this lead sulfide reacts with oxygen, what happens? The lead oxide is obtained. Let us see that how this lead oxide is obtained. Well, we have lead, that is Pb2 plus and sulfide S2 minus, and whenever it reacts with O2 minus, what happens? The positively charged part of this one will react with O2 minus and it forms PbO, that is the lead oxide, with the evolution of the sulfur dioxide gas. So this is all about the fifth number methods of preparation, that is by the action of oxygen on metal sulfide. That means whenever the metal sulfide reacts with oxygen, then what happens and what obtains. That's what all about the fifth method. Now we'll move on to the sixth methods of preparation, that is by the decomposition of the salts. Well, you have the salt, and whenever you give the heat to that salt, what happens? The decomposition of the salt takes place. But if the salt is decomposed, the basic oxide and carbon dioxides are obtained. Well, we have the various salts like the calcium carbonate. When the calcium carbonate is heated, then what happens? We get the calcium oxide with the carbon dioxide gas. Similarly, when the copper carbonate is heated, what happens? The copper oxide with the evolution of the carbon dioxide gas is obtained. That means we need to understand from here, whenever the metal carbonate is heated, then basic oxide plus carbon dioxide is obtained. So how the carbon dioxide gas is obtained? This is a base, of course, but which gas is evolved after this? So carbon dioxide gas is obtained. Similarly, we have the metal nitrates. Whenever these metal nitrates are heated, then what happens? We get some bases along with the nitrogen dioxide with the evolution of the oxygen gas. For example, we have calcium nitrate. Whenever the calcium nitrate is heated, then calcium oxide is obtained, nitrogen dioxide with the evolution of the oxygen gas. And here we need to remember which gas is obtained by the reaction of which substances. We need to remember that one. Similarly, we have zinc nitrate. Whenever this zinc nitrate is heated, on decomposition of this zinc nitrate, it splits into the two or more substances. That means it splits to give the zinc oxide with the nitrogen dioxide along with the evolution of the oxygen gas. So this is a decomposition reaction, and we had already studied about the decomposition reaction in the first chapter of the science, that is chemical reactions and equations. And if you are the new viewer, then I request you to watch the first chapter of the science so that it will be easy for you to understand. So on decomposition, that splits to give the two or more substances. So the calcium nitrate splits to give the calcium oxide, nitrogen dioxide and oxygen. Similarly, the zinc nitrate splits to give the zinc oxide, nitrogen dioxide as well as the oxygen gas. So this is all about the methods of the preparation of the bases. That's what all about today. Thanks for watching. And if you want to watch the next part of this video, I would request you to press the bell icon for the latest notification.